Now I would like to look at how we can use pointers to pass parameters down to a function and to get a modified value back from a function. So first we're going to look at a little function called add1, which does not modify its parameter. So I'm going to pass it a parameter n. It's going to add 1 to n, and then it's going to return the value. Now if we look at main, the value starts out at 9, and I've got a return value, and I print out their values initially, and I'm going to print out the address at which the value resides, and I do that by using the ampersand operator to generate the address. Then I call add1. I'm going to pass the value, and it's going to retrieve or receive the return value. And then I'm going to say, after calling add1, value equals and return value equals. And I'm going to print those both out. So let's just execute this to see what happens. Okay, so it starts out, it says before calling add1, value equals 9, and it's stored at address 8FF-DHC. Fine. After calling add1, which is on line 21 right there, it says value is still equal to 9, but the return value equals 10. And this is quite strange because you watched it modify the value of n right there on line 5, and it says n++. Yet when it returns n, it is assigned to return value, and it is 10, but the value of n, although it became 10, this value in the main never changed. And the reason it never changed was when we call a function, it actually makes a copy of that value and passes a copy down there. Then when it modifies it on line 5, it's modifying a copy, and the original retains its original value. But when we return the modified value of a copy, we're returning the copy, and then we assign that value to return value, so it does get the modified value. But that's because it returned the copy. The original remains untouched because we modified a copy. And this is called pass by value. Now, if we actually wanted to be able to modify that parameter and pass it back, we have to do something called pass by address. And this is shown in our second function, add mod1, which is just going to add 1, but it's also going to modify its parameter. And you know that I'm using not just an int parameter, but a pointer to an int. And that's our key difference. So because I've got a pointer to an int, I dereference the pointer on line 12 here, and I say the value at that address gets 1 added to it. Well, if I pass the address of something, then this will go to the original place where the address is stored, add 1 onto the value there, and now it's going to return that modified value stored at that address. So what we should see is that the value it returns and this value of the parameter are the same in this case. Now I also put a printf in there because I want to show you the address that it thinks it's modifying. So let's run this again. Well, I'll show you a call too. Down here, it says return value equals add mod 1, and it passes ampersand value. So let's run it. And it says, so just before calling add mod 1, value is 9, return value is 10. So value is still 9. Up at the very top, EFFD68 was the address at which value was stored. Here, after we're calling add mod 1, it says I'm modifying the variable at address EFFD68, exactly the same address. So it's actually modifying the variable stored in main at that address, and it's directly modifying the variable inside main. And at the end of calling addMod1, my value has now become 10. It started out 9, now it's 10, and the return value is 10, and they are the same exactly as we predicted. So this is called pass by address, and we pass not just the variable, but its address. Then up in the function, it dereferences the variable, modifies the value at that address, and then it appears that it passes the modified value back. What happens in actuality is it's not passing a value back. It actually modified right here by dereferencing the value, the original value stored at that address in main. So it's not when it returns that the value of the parameter gets modified. It is when it dereferences and changes the value directly at that memory location. You also notice that the names of the parameters are totally different. Here, I called it value. Here, I called it n. Whenever you create a function, you've got the option of renaming the parameters. They don't have to be the same because functions are going to be used for many different pieces of code. The function has got its own name for the parameters, and whatever piece of code calls it will pass different variables or even constants down to it. So therefore, the names don't have to match. So that's a little example of how we can use pointers to modify the value of a parameter and make it appear as if it's passed backwards. So we've introduced the concept of just passing an integer, which is passed by value, and passing by a pointer, which is called pass by address.